Assalamualaikum warahmatullahi wabarakatuh. First of all, thank you for the committee of the conference for me to present our research. Our research, the title is Synthesis and Molecular Docking of Bis-dichlorobenzoyl trimethylthiourea iron 3 compound as anti-cancer candidate. This research is collaboration from some institution, Bakti Tunas Husada, Universitas Airlangga, Universitas Perjuangan, and Universitas Surabaya. This research supported by Kementerian Pendidikan, Kebudayaan, Riset and Teknologi from Riset Dasar Grant in 20 and 21. The outline of our presentation are the first introduction and the second experiment and method, and the 30 results and discussion, and the last is the conclusion. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. First of all, thank you for the opportunity for me to present our research. And the title of our research is Synthesis and Molecular Docking of Bis-1,2,4-dichlorobenzoyl trimethylthiourea iron 3 complex as anti-cancer candidate. And this research supported by Kementerian Pendidikan, Kebudayaan, Riset and Teknologi in penelitian dasar grant in 20 and 21. This research collaboration from Stikes Bakti Tunas Husada, Universitas Airlangga, Universitas Perjuangan, and Universitas Surabaya. And our presentation contains the outline, the first introduction, and the second experiment and method, the third results and discussion, and the last is the conclusion. As the introductions are, according to the World Organization, cancer is one of the leading causes of death worldwide. And Global data in 2018, about 18.1 million new cases of cancer with a mortality rate of 9.6 million. And Ruswanto et al. Has synthesized the composition of 1-benzoyl trimethylthiourea and conducted a hospital study which was proven to have anti-cancer activity is breast cancer. And In 2017, docking was carried out between the complexity of its derivative 1 to 4-dichlorobenzoyl trimethylzurea against the ribonucleotide reductase enzyme and show better activity using absorption and good distribution and toxicity accordingly. And some deficiencies of the complex are permeability and lipophilicity, which are less supportive for the process of interaction with biology membranes. Therefore, it is necessary to modify it to be complex with metals, one if which is iron. Based on this background, researchers conducted research in developing anti-cancer drugs by synthesizing complex composition of compound 1, 2, 4-dichlorobenzoyl trimethylthiourea with iron metals. Then do the profile and characterization. With its HSM, UV and spectrophotometry, infrared spectrophotometry, mass spectrometry, as well as complete testing in docking, predicting absorption, distribution, and toxicity properties. And for the experiment and methods, the first synthesis of the complex compound. The initial compound is methylthiourea as much as 1.333 millimole was dissolved in 30 milliliter ethanol is a solution A. The 0.564 millimole of Fa was dissolved in 10 milliliter ethanol is a solution B. Then drip slowly into solution B. The dripping process was carried out consistently in low heating. Then there were reflux for 7 hours at 75 degrees, while continuing to be stirred using a magnetic stirrer. Then the evaporation of the solvent is carried out using a rotary evaporator. Then the precipitate is dried. And the second step, identification and characterization of synthesizing the compound. The first, the purity test. The second, UV visible spectrophotometer. And the third, infrared spectrophotometer. And the last, mass spectrophotometer. And then we conduct the computational study. And the computational study, we done some of the procedure. The first, preparation of protein structure and ligand. And we get the complex with the ID code 2AUD. And then we done the molecular docking. We use the autodock, and this parameter we use in our docking. And the last, we predicting the absorption, distribution, and toxicity properties with the web solver. And for the result and discussion, the synthesized results with percent recovery as much as 97.85%. Synthesized compound in the form of powder, yellow in color, smell distinctive, slightly soluble in water, and dissolved in ethanol. And then from the purity test results, melting point test is use the ensure that the compound complex waste forms. The compound can be said to be pure if it has a melting point of the compound from starting to melt until it melts completely is less 2 degrees Celsius. The result of melting point distance test are listed in table 1. From the table 1, we get the melting point distance, and then any difference from FHL3 and the initial compound and the complex compound is different one the other. So in this case, we get the new compound is complex, and the complex is pure because the melting point distance we get the different as 2 degree. And then the complex compound, we continue by identification and characterization of synthesis compound. Identification and characterization of the synthesis compound was carried out with UV spectrophotometry, infrared spectrophotometry, and mass spectrophotometry. And we get the data as table 2 and table 3. In table 3, we explain the UV spectrum result. And then we saw the Fa and the initial compound and the complex compound in different lambda max. And then the magnitude of the shift of lambda max, absorbance, and a molar absorptivity and the cleavage energy, the complex are shown in table 3 as below. And then we got the air spectrum as figure 1 for detecting the functional group in the complex compound. And then we get of the functional group of our compounds was detected. This is some of the functional group of the compounds, and this is the if number from initial compound, and then this is the complex compound with a number of the functional group in our complex. The difference in our complex get the interaction in ion oxygen and ion nitrogen, but in initial is no. For determination of molecular weights of the complex compound is on the result of mass spectrophotometry. The molecular weight of compound complex 585.98 gram per mole. The structure of complex compound and mass spectrometry data can be seen in figure 2 and figure 3 as below. This is the predictive of the structure of the complex compound. This is the interaction, ion and oxygen, ion and sulfur, ion and nitrogen. So this is the mass spectrum for the molecular weight detection. This is the molecular weight detection of the complex compound. We get it. So from the identification and characterization, we get the complex compound as our target. And then after we get the complex compound, we continue the computational study. The first, we done the validation of docking methods is to ensure that the method was valid and can be used for other research for docking with autodock tools. This method have to be valid if value of root mean square deviation of less than 2. And from validation docking, getting smaller value of RMHD is mean that the ligand prediction always have similar pose with native ligand. Validation result have RMHD value of 1.19 angstrom. The RMHD is a parameter to show the similar between docking ligand and native ligand. This is the picture of the overlay of the native ligand and docking ligand. The native ligand is blue and docking ligand is red. Except that we get the binding affinity or constant inhibition. And we can explain that the hydroxyurea we get the binding affinity minus 3.38 and the initial compound minus 6.66. And the complex compound we get the binding affinity of minus 7.74. And the significant with the inhibition constant. For the table 5, we concluded that the complex compound more stable than others. Hydroxyurea or initial compound. After that, we done the visualization with discovery studio. For 2D visualization, we get the interaction in hydrogen bonding and hydrophobic bonding. This is types of hydrogen bonding and hydrophobic bonding from our docking. In hydroxyurea, in initial compound, and the complex compound. And example, in the complex compound, we get the 1, 2, 3, 4, 5 hydrogen bonds, and the hydrogen bond of the complex much than the other. So I think the complex compound more stable than others. And then we done the absorption, distribution, and toxicity prediction of the complex compound. We get the data in table 7. The parameter we calculate of human intestinal absorption, CaCO2, and protein plasma binding. And we get the toxicity test, the name of Ames test. From the table 1, we concluded that the complex compound may be better than the other. Absorption, distribution, and toxicity almost similar in the other. And the conclusion of our research is on the research that has been carried out. It can be concluded that with 1,2,4 dichlorobenzoyl trimethyldiurea iron 3 complex compound can be synthesized through a reaction between FHL3 6H2O with 1,2,4 dichlorobenzoyl trimethyldiurea with 97.58% of percentage recovery. And from the docking result of the complex have good interaction with the code PDB receptor to IUD, which is better than initially advanced with binding affinity of -7.64 kilocal per mole, and inhibition constant is 2.11 micromolar. And with thanks to the penelitian riset dasar grant from the Ministry of Education, Culture, Research, and Technology of Indonesia in 20 and 21. Thanks to Stikes PTH for the provision of the facilities to complete our research. And thanks to our collaboration, UNPER, UNER, and UBAYA. Thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.